And good morning from sunny Melbourne. Okay, ready to go. Pepsi Max is the best gut, right? Yeah, well, Sion, if you could just make a cup of coffee for Long Flare, that might help keep the peace around here and everybody will be happy. Stephen, yes, there will be lots of squirrels. Andy, yes, it was a last minute camera rearrangement. But before I get into this, the important thing, I acknowledge the traditional owners of this land. I pay my respects to their elders past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, and yes, I know that whole thing seems very weird to some people, but I want to do it, so I'm going to do it. Mitchell, good to see you here. Who else have we got? Carlos. I think I've mentioned everybody that's spoken up in the live stream. So yes, today is going to be squirrels. I do have one idea. No sugar, okay. Iggy wants to know, are pants optional during lockdown? Aren't they always optional? I don't think lockdown has anything to do with that. Mr. Fix-It. Mako, Gary. Good to see you all this morning. Now, so this morning when I was setting up the stream last night and I just added it on the schedule, I didn't put a specific thumbnail on it. I just used the generic thumbnail because my plan was to go into this in a totally, let's just see where this goes sort of thing and chase squirrels for a couple of hours. But I do have one specific thing that might end up taking 2 hours. So if nobody has objections, I think I will begin with that. And that is, James, I made it from the good land, Milwaukee. Yes, as Sion says, pants are always optional, lockdown makes them unneeded. Yep. Oh yes, Mako, you're right. I need a version of the live stream thumbnail with Steve on it so that we can have a squirrel thumbnail. G'day Jacob and Scott. Thanks for coming along. So what I was thinking of doing is going through the current state of the multimeter, the UT61E Wi-Fi interface, and showing where that is up to at the moment, because it's in a really, really good state. It's after cable ties work on the decoder. So what he did was take a UT61E, well actually specifically for the controller chip that's in the multimeter, he got a packet decoder that was written by someone else, I think in Python maybe, and he's ported it to and embedded it within the firmware for the multimeter interface, which means that it can now spit out values. It understands what mode the multimeter is in, what the range is, and all of that sort of stuff. So what it can do is not just report the raw packet, which is what my original firmware was doing. It now actually decodes the packet and provides the data, which is fantastic. And then Aaron has been doing his continuing with his magic in Node-RED and updating the Node-RED client so that it understands the data that is now being sent by the updated firmware. So the two of them have been collaborating on Discord, and the result is a system that actually works really, really well. So, yeah, I think it's probably worth, it's sort of at the point now where the hardware is available. So if you want one of these adapters, then you can get it. And at the moment, there are no instructions anywhere for doing the software setup. So right now, if I've shipped you an adapter, it's kind of been left to you to figure out what to do. So maybe I was thinking of just showing you the current state of the firmware and installing it on the adapter and the Node-RED client, because it really does look cool. So, where to begin? Okay, what I'll do is, Cheetah Kid, hey, thanks for coming along. Intermittent Tech, Cool. Intermittent. Oh, I just gotta say, Intermittent, your recent video on your illuminated house sign, really cool. That it looks fantastic. Nice intro too, with the the moody music and everything. So for those of you who don't know, Intermittent Tech does live streams and videos about. He's done some really cool ones about addressable LEDs, and a recent project was taking a house number, putting LEDs behind it so that it can do different patterns and things, and it looks amazing. Really, really cool. So yeah, if you walk up to Intermittent's house at night, I think it would look pretty spectacular. So, now, where was I? That's right, the multimeter interface. So, I'm going to put the chat aside just for a moment. So if you, some call it fun is here. Welcome. So I'm kind of going to ignore the chat for just a moment because I am going to get my head around how I'm going to show this. All right, I think the first thing to show you is, now I'm just looking around on my desktop because I need to find, where is it? Okay, GitHub. All right, I'm going to start off by showing you on the desktop. Let's see if this works. Yes, it does. Okay, so we've got, because of the position of everything, you can't quite see. All right, the place to go if you want to get started with this is linked from the page as well. So if you do have one of these UT61E Wi-Fi devices, the product page for it, I should show that as well. No, not that, UT61E. Now, will this shortcut take me there? It should. Yes, it does. Okay, so it feels like I'm like a telemarketer or something at the moment. Spruiking the products. That's not really the intention. It's just to show you where the information is. So if you have one of these, one of these Wi-Fi interfaces for the multimeter, and you can scroll down, you'll see that it says design files on GitHub. And where that will take you is here. It's got all the design files for the hardware. So we've got the schematic and the board files there. And a bit of info about it. And Cable Tie and Aaron have been doing amazing work on the software related to it. So inside here, there are a couple of things. If you have the hardware, the first thing that you'll care about is the firmware. You need to load this onto it. And this was recently updated. You can see that there are 3 directories in here. 2 of these you can ignore. The first one was you can see based on the date, the UT61E serial reflector. This was just a really simple sketch, and all it did was read from one serial interface and output to another serial interface. So we were using software serial, and that was my first attempt at simply getting a device that would take the data from the optical interface and pass it straight on, no questions asked. And that basically just proved the basic communications was working. And then down here you can see Wi-Fi Lowland 32. This was the version that, this was the first version that we kind of got working, and this was based on a Lowland 32. But then the proper version, this thing, has a D1 Mini on it. Let's go over to there. There's a Wemos D1 Mini, which is an ESP8266. It's not an ESP32. So this one, the one you want, is UT61E Wi-Fi D1 Mini, which has got the most recent date on it, so it's pretty obvious which one it is. And so what you do is you grab this and download it and open it in the Arduino IDE. And there's a whole lot of documentation that Cable Tie has put in here, which is really cool, showing all the meanings of the different bits of information that come back out of it. And okay, so what you'll see is that there is a config.h-example file. And when you open this project, there will be no config file. So what you need to do is copy config.h-example and just rename it to config.h, load it up in the Arduino IDE, and you'll be ready to go. So I'm just going to show you the example file. So what you need to do is edit it to put in your Wi-Fi network and password. You can put in your MQTT broker, and if you've got a username and password, you can put it in there. This is probably pretty small and hard to read, isn't it? So, zoomage. Okay, so basically you shouldn't really need to change very much in this. The important stuff is just get it on your Wi-Fi and get it pointed at your broker. And that should be it, basically. You shouldn't really have to care about the rest of it because this is set. This is fixed in hardware. Yeah. So once you've done all of that and you've got it loaded up in the Arduino IDE, let's okay, this one. So I'm not going to show you, I'm not going to go through this in great detail, so I don't, oh yeah, let's have a quick look. Come on. Preferences. I'm just going to make this a little bit easier to see. Let's make it 18-point font. There we go. It's a little bit easier to read on screen now. And so what cable tie has done, enhance, yes. So what cable tie has done is add UT61E display.cpp and .h. And what these are done, oh, based on, cool. So that's where the original thing came from, the decoder. That's really screwed up. Check out how the font is all wrapping over itself. That's de-enhance. Oh, that's making a mess. Looks like the Arduino IDE can't handle going to 18-point font. Let's try changing it to 16 and see if we can read it. Yeah, that's better. Okay. So what this does, I'm not going to go through this, mostly because I don't understand it. What it does is take the raw packet from the multimeter and it extracts all the relevant things. So it looks for the specific parts of the packet and then uses these masks to set values. So these are bit masks that are used for mapping purposes later on, but we don't need to go into that because cable tie has, oh, Mako said maybe a different font. Yeah, perhaps. So cable tie has taken care of all of that, which is awesome. So now the firmware, when it's loaded onto the Wi-Fi adapter, will output all of that information. And I'm not going to click on my config because that will show you my Wi-Fi details. But this is the version that is currently loaded onto my adapter, which is plugged in just over there. So let's hang on. I'm going to see if I can find which one is it. I'm just looking for the right port because I want to. This should be it, I think. Let's see if we can open the serial console to it. Oh, here we go. Check this out. So this is live data being reported in the serial console just over the USB connection. And so my multimeter is turned on and you can see a whole lot of stuff here which is all done as JSON messages. And that is also being reported to MQTT. So when it starts up, in fact if I turn this, let's see if I can get this sorted. I'll turn the multimeter off so it's not outputting data anymore. I'm going to hit reset on the little adapter. It starts up and look at that. You can see that it's reported what its topics are going to be. So if we subscribe to this topic, let's see, if I do item, is it going to throw me to another screen? No. Cool. Now, do I have oops, mosquito sub minus H which is the, and yeah, I think that's it. So what I'm doing here is just subscribing to the topic that it's reported. So if you've installed it for the first time and you don't know what the topic is going to be, open up the serial console and it'll tell you right here. So I've grabbed the JSON topic in this particular case, and then I'll turn the multimeter back on and we should start getting some data. If things are working, yes, cool. So now we are seeing the messages that are being published to the MQTT broker, and you can see the values are pretty much zero. But if I grab the multimeter probes and just stick my fingers on them and induce some little voltages, you'll see the values on the left changing. So now we have data coming from the, and you can see the range. If we look down here, you can see display unit V and mode voltage. So if I change the range to millivolts, you can see that the range has changed. Change it to ohms range, and it says mode is resistance. So we are successfully getting the data coming off it. So that is two of the three important elements, I suppose, in this project. The first is the hardware, which gets the which interfaces with the multimeter, and it gets the connection to it, like the electrical connection. The second is the firmware, which decodes the packet and then pushes it to MQTT. And then the third is, what do you do with this data? So we need some way to display it. And this is where Aaron's work comes in, which is really cool. Now, if you are looking at this repo, the interesting thing, so this is where in future this project could become much more interesting as well, because the data side of it is pretty much taken care of now. There might be some minor improvements to be done to the firmware for, packet decoding in edge cases and things like that, but it's basically working. It's taking the information from the multimeter, decoding the packets, and pushing it to MQTT. So the data is there, it's available for us to use in whatever way we like. The question then comes in, what do you do with the data? So this clients folder at the moment only really has one thing in it, but over time it would be really cool to see more things in here. And I've got some ideas for ways that I want to use this now that the data is being published properly. So at the moment we've got a Node-RED folder, which is for Node-RED clients. And ultimately there should be multiple Node-RED clients in here. Right now the only one in here is this one made by Aaron, but there might be others, because this one is for a web-based UI using Node-RED. But we might want to make another node here which does things like take the data and stick it into an InfluxDB database, or create a chart from it or something. There are all sorts of different things. So what we could end up with is multiple clients. And this is the Node-RED clients, but then we could end up with desktop clients. Aaron's already been working on one of those. Yeah, we could end up with all sorts of things. So this client side of it is really where the interesting stuff is going to start happening. But let's have a look at the Node-RED client. So this is Aaron's, he's got some explanation on here, but one thing that is not really explained here is how to install it, because it's one of those things that when you've done it, you know, and when you haven't done it, it's kind of hard to figure out the first time. So let's have a look at how to do that. All right, right here I have one already. I'm going to get rid of this, I think. Will I? Let's just take a look in here. Yeah, okay, I'm going to delete it. So I'm going to start with And I'm going to delete this one from here. Edit properties. Where's the delete? Where's the delete? Oh, no, it's from there. Delete subflow, wrong place. Okay, so what you do is go into Node-RED, and the first thing we're going to do is go up to here and do import, and we want to stick in a new node. So at the moment, if you've got the repo, okay, so in the repo, in clients, Node-RED, there is this file, UT61E Node-RED Web UI JSON. So that's the one that we want to import. So in here, select a file to import, and I'm just going to drag that in, zoink, and open, and import, and oh, already exists. Oh well, import copy. Stick it in there. Okay, and that'll be because I hadn't done a deploy after deleting the old one. So what we've got now, if you look down on the palette, is there's this new section called Superhouse, and it's got Superhouse UT61E as the node that's in there. So then we need an MQTT subscription, and in this case it's connected to my my unauthenticated MQTT broker, and the topic that you put in right there is exactly the same as what we were just looking at. So this is the topic that is reported by the, oh we can't, oh yeah, there. It's this topic that is reported. So when you start up your multimeter interface without any data coming through, it'll tell you what topic. Just copy that, paste it into here, and with your MQTT broker set up, and you'll be done. So this will be the data coming from the multimeter. We need to feed that into Aaron's node here, and we've got a debug thing here so we can see what's going on. That's not actually necessary, but it's in there. So if we go and have a look in here, we'll give this a name. Oh, we don't need to. We'll just leave it as it is. Now this thing here, you can see Web UI URL UT61E. You can probably just leave that default, but you can customize this to change the URL that it appears at. So we'll say done and deploy, confirm deploy, and once it's finished, we should now have, oh, Andy said, or MQTT to InfluxDB to Grafana. Yeah, exactly. So I'm interested to see what people do once they've got these multimeter interfaces and start messing around with clients. And if you do build stuff, please share it, because I'd really like to see more stuff in here. So what we've got now is, I'm just going to move this so that you can see the URL. In fact, what I'll do is I'll just open a new window. I'm going to open a new window right here. And what you do is you go to the URL of your Node-RED installation, and then you add UT61E on the end. And it will load Aaron's interface, which is super cool. So now if I turn the multimeter back on, oh, it is on, okay. There, I'm just messing around with the probes, and you can see the values that are coming in. If I'll turn on a power supply and stick the probes into it so that we've got something that we can see. In there. So I've shoved the probes into the into the output of the bench power supply, and you can see that it's got a value there, which is super cool. So now we have a web interface, and in so where all of this started, the whole point of this was I wanted to be able to work on my bench here and have the multimeter display come up on the screen for the live stream so that you can see it. And so OBS has a built-in browser, and this URL right here, if I copy that, I'm going to go up to my, you can't see this bit, but I'm going up to my OBS interface. So if I turn that on, okay, so what you're looking at right there in the top left, This bit here that you can see on the screen, this is Chrome loading up the web interface, and I can move it around because it's just capturing my desktop. The other, if I just move my cursor, this other display that's over here on the left, that's not actually on my desktop. That is OBS looking directly at Node-RED and inserting it as an overlay onto the screen. So I'll just close this one to get it out of the way. So now if I went to say overhead, I've got to turn it back on, turn it on there. So now, this is the cool bit. I can grab this and I can be doing stuff here on the bench, and you can see exactly what's on the multimeter. So the multimeter that's in front of me on the bench is the same as what's coming up being imported into OBS Live, and you can see the values on the screen. So that is, to quote someone, mission accomplished. So we now have, switch back to desktop. So we now have data live from the multimeter coming up in the live stream, which is, how long has it taken to get to this point? It's been a really, really long time. Ooh, nice. So Aaron said, I've been talking with Cable Time. We're looking to add the same UI directly into the firmware for those who don't have Node-RED. You would just access the device's IP to access the UI. That would be awesome. And then you could just power it, yeah, somehow. So there are more things we could do with this. Down the track, I think one of the biggest things is power. Sorry, I'm distracted because there's something weird going on in my OBS display up in the edge of the field of view. What is happening there? I don't know what's going on. No, I think it's okay. It's okay. It's just a weird thing because of the way what you're looking at now is a desktop capture, which is a small portion out of the middle of my monitor. And so OBS is doing a weird thing where it's displaying area around it, but that's not what you can see. You can only see a section of it. It's kind of disconcerting. Yeah, so, where are we at? Good morning, everyone. Welcome to the live stream. It feels like I need to be starting from scratch. Oh, okay. Aaron and Cable Tie, that sounds really cool. Being able to, yeah, implementing the web interface directly on the device would be really cool. And yeah, so as I said previously, my original objective for this was to build something that that I could use on the live streams, but it would also be useful in other situations. So the really nice thing would be if the multimeter just had Wi-Fi and everything built in. Essentially what I'm trying to do is add a feature that the multimeter didn't have in the first place. So it didn't have Wi-Fi, and oh, Cable Tie, you're here too. We've just been going through all the multimeter stuff. So I just showed some of your firmware. Yeah, so at the moment, I see it as a little bit of it's a compromise making an external device rather than having all of this built into the multimeter. One of the reasons that I did that was we could physically fit the device inside the multimeter. If I took the back off it, I could put that board, maybe with some slight changes, I could physically fit that board inside the multimeter and wire the data pin directly to the data output from the multimeter controller. The issue is powering it. And we really need, a multimeter will last a long time on a 9-volt battery, but an ESP running Wi-Fi will not last a long time on a 9-volt battery. So that's the big issue. it would be really nice if this was physically inside the multimeter, there was no external obvious indication, and you just turned the multimeter on and it started up the ESP, fired up its web interface, and you could just stream the data off the multimeter. That would be awesome. Yeah. Oh, Aaron says hold, low battery, continuity, etc. all works too with icons on the UI. Yeah, it is really, really cool. So Dodgy suggested a rechargeable 9-volt battery, and so going to some other kind of battery pack is an option. Cable tie. Yeah, that multimeter interface. Who did that? Yeah, you can get batteries now in a 9-volt format, which internally are a different chemistry, like a LiPo, so that you can then take it out and recharge it. But yeah, I don't know what the energy density on those sorts of things is like. Anyway, that would be that's definitely worth looking into. Let's find out. 9-volt. There's a technical cell for a 9-volt. There's a name for a 9-volt battery, but I don't remember what it is. 9-volt battery LiPo. Let's try this. 800 milliamp hour 9-volt USB. This is the first match on eBay. Plus, let's check this out. It's a $12 battery with $71.50 in postage. All right, I don't actually care too much right now about postage and stuff. I just want to see the tech specs. So what does it say? 800 milliamp hour. All right, 9-volt, and looks like it's got a charge status display on the side, which is pretty cool. So one option would be to go for something like this, a lithium-ion battery, 1000 milliamp hour. Here's another one. Oh, this one's lithium-ion, 1000 milliamp hour, 9000 milliwatt hour, micro USB. Interesting. Another option would be to not necessarily try to, what we need is some kind of a pause button, like an online pause button that flashes up a little light here that I can see. So when you press the button, and then when you press it again, I just unpause. So that would work for everybody. So when one person pauses me, it pauses for everybody. And then you don't get out of sync. It's not a problem. That'd be so much better. Yeah, so what are we looking at here? 1000 milliamp hour. That's 9000 milliwatt hour. That's an interesting way to be expressing this. I mean, I understand why they're doing this. It's 9 volts, 1000 milliamp hour means you get 9000 milliwatt hours of power out of it. That's, yeah, okay. And it is, so it's lithium ion. But basically what this means is that a multimeter, instead of running for intermittent use for multiple years on a 9-volt battery, it would run for maybe multiple hours before you'd need to recharge it. So yeah, it'll be okay, but it's not awesome. So maybe another way to do it. What I haven't looked at, maybe this is time to be looking at this. Let's see if we have, now in the resources, do we have the schematic? Yeah, circuit diagram. All right, here is the circuit diagram for the multimeter. And let's have a look at it. Where is it getting power? Oh, here we go. Oh no, that's the test. Why can't I see it? VB blah, VC plus, where is the connector? I'm sure everybody else can see it. Hang on, I'm going to zoom. I'm just going to adjust the size of this to get it on screen. Common. So these are the 4 sockets on the front where the test probes plug in. Oh, here we go. Bat 9 volts. VB. Okay, so let's see what happens with the battery. So positive goes to VB plus, and it'll be doing its own internal low battery testing, of course. These are switch contacts. This really weird thing here with all of the squares on it, these are contacts inside the rotary switch. So as you turn the switch around, it makes and breaks different sets of contacts in a kind of complex fashion, so that it does things like connect different inputs depending on what mode you've selected, and the mode values here, these bits, FC4, 3, 2, 1, those are, I'm not sure what FC stands for. I think it might be something like function control. And these are the bits. So it's a 5-bit input, and we're only caring about 4 of them. So the value of these 4 bits, if you drive these 4 FC1 through FC4, if you drive those 4 logical inputs on the multimeter controller, oh, here we go, and you can see the explanation. Depending on what these are set to, you get different modes. So these modes are being set by the rotary selector on the front by making and breaking different contacts on here and changing. Like, so we can see FC1 comes up here, along here, and it goes to that contact and that contact and that contact. So it can be pulled high, low. That's a ground connection. Okay, anyway, I'm getting off track. What I was looking at, what I was really curious about is, do we have to use a 9-volt battery? Now, it's going to complain about low voltage if we if we stick something like a 2S LiPo in there, which is nominally like 7.2 volts, or it goes up to about 8.4 when it's charged. But is it really going to care? So we've got VB plus, which is voltage battery plus. Somewhere on here, I would expect to see, how is it that I'm not seeing it? Somewhere there is a voltage regulator. There's gotta be. There's just gotta. Yeah, this is one. Oh, hang on. Yes. Here we go. Is that it? What have we got here? VC plus and VB minus, and N and G, so ground. What is this thing? That looks awfully like a voltage regulator to me. Normally these symbols would be out in ground, I think is what they stand for. So we've got V minus coming along there and LBAT9 there. So this voltage divider is what it will be using to determine whether the battery level is low. Anyway, what I was just trying to figure out was, oh look, VR3, there's a OVX. Wonder what the OVX pin is. Yeah, don't know. Anyway, I have a very strong suspicion that if we simply powered this multimeter off a 2S LiPo, it would be perfectly happy. It'd complain about low battery, I'm pretty sure, but it should work. And we could put a... So anyway, where I was going with with these thoughts is, with something like a 2S LiPo, we could stick one on the back, and we could have significantly more. Let's see, 2S LiPo, I don't know, let's say, oh, this is kind of on the large side, but say 2000 milliamp hour. How big is one of those? So what you could do is, oh well, here's a, is that a single cell? Yeah, that's a 3.7 volt single cell, 2000 milliamp hour. But basically you get a 2S version of that. 850. So what it could have is a little 3D printed enclosure that goes on the back and that clips into the normal battery compartment. and sticks a big battery on it. Maybe it'd work then. Anyway, my motivation to pursue that is a little bit iffy, because for my personal use, the actual reason I started this was to be able to show multimeter data on the live stream. And for that, I'm sitting here at the bench. I'm not caring about battery power. I've got power to the device through USB, so that's fine. It's optically isolated from the multimeter, which is a plus, because it's just using the external optical interface. So this has actually 100% satisfied my goals. What you see on the screen right here is perfect for me. Development could stop right now, and I'm very, very happy. So yeah, my expectation of building an interface that looks like what you can see on the screen now, this is beyond what I originally had in mind. My wild dream was that I would be able to have just some numbers on the screen, like maybe down here or something. I could just have like a transparent background numbers, and it would just say 0.00V or something, and that would be it. And probably only have voltage range, like just volts and nothing much else. The fact that we can do all of the different ranges, like I can come over here and go, ooh, look, I can spin into different modes, millivolt mode, and ohms range, and the display updates. And it's got the Unity logo on it and everything. That is so cool. Yes, it has surpassed my my dreams, and that means that my motivation to keep working on it is pretty much gone, because I'm done. But what I would really like to see is other people continue working on this, and I know that Aaron and Cable Tie are keen. So having other clients that can consume this data and maybe chart it over time or whatever, that would be really cool. The other thing that this could be useful for is in some kind of automated testing. Like if you're building a test rig for a product and you want to be able to do something like load up a power supply and measure the current and measure that the voltage stays within parameters, this basically solves the problem. So obviously you can cobble things like that together, and there are other ways you can measure it. Like there are definitely existing tools that allow you to interface with instruments and log the data or make decisions based on it. But I really like the idea of a low-cost multimeter like this with a little device plugged into it, and now the data is on MQTT, because that gives so much flexibility. If you've got something like a test harness which is written in Python that is driving your test rig, then it can subscribe to MQTT and it can get access to the data. So it can do things like change settings on your device under test, and then pause briefly to allow things to settle, read the data coming off MQTT, check if it's within parameters, pass or fail the test, whatever else. So that would be, yes, that would be a very handy use for this. All right. Yeah, and in fact, I know there are situations where, so there is a test rig that we built, I think, how long ago was it? I think it was about 11 years ago. We did a test rig that was set up in a factory in China for it was for the Ether 10, I think. No, it was before that. It was for the Ethernet shield with PoE. So what we did was have a test rig that supplied PoE down the wire, and what we did was load up the power supply. So the system had a chunk of really big wire wound resistors of low value, that would put a known load on the system. So it would pull a certain amount of current out of it. And then at the actual test system in the factory in China, what they had was multimeters, like they had a lab power supply and some multimeters and different things. So what they would do is in the test specifications, it would say that you need to load it in a certain way. And then the instructions were observe voltage across load and check it is within a certain window. And if it was above or below that particular window, then you fail the test. So, well, you don't fail a test, you mark the thing as failed. So, but that was a manual process. It was someone sitting there in the factory looking at the multimeter and saying, no, this is out of spec, fail. And anytime that you can automate testing like that is a good thing. So doing that now, I think what we would do is have something like a multimeter which is automatically measuring it, and have the data from that built into, have the data from that acquired by the software that's running the test, and then at the end it just gives a pass or fail result. So the person who is running the test doesn't have to be sitting there making a judgment call, and then you have human error come into it, like their mind is wandering because they've just tested hundreds of these things and they've been sitting there for a couple of hours. So one is outside of spec and they don't notice, or it's just on the borderline of spec and they think, that's going to be close enough, and they let it through when they probably shouldn't. You know, all of these sorts of things. So being able to measure things automatically, I think, is a really, really useful thing. Okay. So, oh, Mark says, don't lithium batteries have more energy density than alkaline? I actually don't know. I think so, but I don't know. This is certainly a decent amount of energy capacity in this cell for a little 9-volt size cell, battery in this case. I should try to use the terminology correctly. It is a 9-volt battery that consists of cells, so 9,000 milliwatt hours capacity is pretty good for a little thing like this. So yeah, lithium ion does seem to do a pretty good job. Okay, now, has anybody queued up some squirrels for me? I need squirrels to chase because it's only 10:48 a.m. and I've been talking about this multimeter thing for the whole live stream so far. So let's chase some squirrels. Okay. I'm just going to take it off the desktop so I can drag something else across from it, and let's see. Now, you're jumping the gun, Chip. It's not lunchtime yet. Not yet, not yet. Well, maybe for some it is. Some Call It Fun says, sounds like designing for testability could be an entire stream topic. Yes, it could. I'm not an expert on it. I've had to do it. Oh, Andy says, too early to mention project. No, you can go ahead and mention. All right. Sorry, I'm jumping around at the moment because I'm trying to settle on a subject. Designing for testability. Being a test engineer and designing for testability is a huge subject with that needs a lot of very specific knowledge and skill and techniques and things that are used. I have done it, but I am totally an amateur. I've just done it from the point of view of I need to test a whole lot of these things. It takes me ages, so how can I optimize that, streamline the procedure? Now there are certain things that what am I trying to say? I don't know. I was going to go down the track of talking about some of my my opinions on testing, but that was right after saying I'm not an expert. I am definitely not an expert. I have designed a bunch of different test rigs and defined tests and spent way too much time running tests. But, ooh, Unify Management Interface. Ooh, Aaron mentioned something. Okay, so there are a couple of... oh, Paul also... Okay, there are a few things coming up here that we could talk about. DefPom, hey, thanks for coming along. So Paul said, what about an oscilloscope display just like the meter? Processing could receive the data and output the graph. Okay, now, a couple of thoughts about that. All right, I will try to stay on this topic just for a minute because I know I'm jumping around all over the place right now. Hang on, I'm going to change views to side camera. What you can see right here, just get my anti-static strap out of the way. This is the Make E Happy strap. This thing here that you can see is a USB camera on a little aluminium bracket. Why does the camera keep jumping around? Don't know what's going on there. So that on an aluminium bracket which sticks out and it points directly at the multimeter interface. And it kind of works in a, just going to turn on the oscilloscope. So it kind of works in a dodgy way. I'm just going to plug in the camera. I've used this in the past and it's not very good. New audio device detected. No, don't switch. Don't switch. Can I get the... Okay, I'm going to go to a different view. Oh, hang on, USB cam, maybe. Nope, that didn't work. All right, desktop view, nope. I want to go to overhead camera view and... Oh, I know why it's not here. It's because I haven't used it since I switched to the M1 Mac Mini, so I don't have the input set. But anyway, I've got a camera pointing at the screen of the oscilloscope and it works, but the camera is a little bit crappy. Now the alternative is to pull the data directly over either over the network or over USB. This oscilloscope has it's got a network interface on it, and I have done that. There is a Python client that will talk, what's the protocol called? Skippy or something? It talks over the network to the oscilloscope, and it pulls frames off it, but it can only do 2 frames a second. And so the result is that you get absolutely perfect reproduction, because the multimeter is directly providing, essentially the multimeter internally is taking screenshots of itself and then sharing them over the network. So it is pixel perfect. It's exactly what is represented on the screen here, but it's only 2 frames a second, or is it 1 frame every 2 seconds? I can't remember, but it's really, really slow. Yeah. So, ooh, DefPom said, my Oscilloscope has a web server so you can view it in the browser. I just full screen on my second monitor and share that. Yeah, that would be nice. Unfortunately, this Rigol does not have that. So, even though it's slow, I've been leaning towards going back to using the Python method and just pulling the frames off the oscilloscope, because say 1 frame a second or 1 frame every 2 seconds, for our purposes, I mean, if you were trying to actually use the oscilloscope and the interface was running at say 1 frame per second or 2 frames per second, that would be horrible. It'd be a really, really bad experience, because as you're switching through, like changing the time base or changing the voltage scale or whatever, it would be really, really slow. You'd change it and then you'd wait for a little while and then you'd see a new view. But it's probably acceptable for something like a live stream, because for me, using it locally, I would be seeing it at full speed, the screen updating live. What you would be seeing is a snapshot of the screen updating once or twice a second. And that's certainly enough if if I'm doing something like probing a signal and capturing it, and then, you know, we're just looking at the captured signal and yeah, and sorry, I was just distracted by a comment. Yeah, if we're just looking at a signal and talking about it, like say I captured some I2C signal or something, and then we were looking at whether the signal was clean, you know, that sort of thing, you don't actually care about the frame rate because you've got a static capture anyway. You're just sitting there looking at it and maybe zooming in and examining things like the edges and checking rise time and overshoot and all of those sorts of things. But you don't need a high frame rate for that. So my dodgy little camera pointing at the screen solved the problem with frame rate because it would come out at 25 or 30 frames a second or whatever I'm streaming to YouTube. But what you saw on the screen was just a little bit fuzzy. It wasn't that great. All right. Aaron says, I'm happy to do another web UI for it. Just need someone to pass me the data as JSON. I don't think that's very practical with a, yeah, with an oscilloscope. Okay. All right. So, where are we at? That's right. Testing. I'm talking about testing. So, something, okay, testing. What I was going to do, I'll just turn off that scope because I can hear it sitting there spinning its fan. It'd be nice if it was silent. One of my goals for setting up gear in here is to make everything as quiet as possible. So when I just sit here and don't say anything, I can hear a couple of very high-pitched whistles that you probably can't hear. But just things like the sound of the monitor, because monitors make like an extremely high-pitched sound that you don't even notice. It's most of the time, but if you're in a really quiet room, the reason I'm looking around is I'm just trying to find, here we go. I was just trying to find some cables because, wrong one again. I want that. I was just doing some testing on this, and a few people on Discord saw me talking about this the other day. So what I've been doing, all right, more of the backstory. Where is it? Over here. Okay, and I'll unplug that. Plug that in here. Since we're kind of on the subject of test stuff, I might as well show you this. All right, so this is one of the Rack 32s. I'm still waiting for these PoE modules. Now, I am very concerned that what I've done here with the PoE bypass is not going to work. But we won't know until the modules arrive. And if it doesn't work, I know how to fix it. So it'll be a very simple revision. But anyway, we have these Rack 32 boards, and what I was wanting to do was test these. Oh, look at all those solder joints. So there are more than 200 hand soldered joints on one of these boards, unfortunately, even after all of the pick and place has been done. So assembling these takes ages, but testing them takes ages. Because the way that I've been testing it, I'm just going to turn off the where are we? UT61, turn off the multimeter display. There we go. Have a bit more view in the camera. So the way that I've been testing these previously is, I've got to scroll back over here again. Scrolling in the real world. It's called rolling. Okay. What I've been doing is using this little set up for testing. And I was running the light switch controller firmware on this and have that plugged in here and then power it up. So this is just explaining the test procedure I was using, which was incredibly laborious. It was easy to set up, but then it took ages to run, because what I would do is just use the regular firmware that runs on the light switch controller, plug it into Ethernet, power it up, so it'll be reporting to MQTT, and that would power this up. Then I would grab a 4-way light switch, so I needed the 4-way version, plug it into the first port, and then I would watch the terminal, so I'd watch MQTT basically, and press the first button, and I would see an event pop up in MQTT saying button 1 pressed, and then press button 2 pressed, button 3, button 4. And the thing to make sure of was that when I pressed button 1, it would only say an event for button 1. If there was a solder bridge, for example, on here on the resistor network between button 1 and button 2, then when you press button 1 in MQTT, it would report button 1 event, button 2 event, basically at the same time. And then you press button 2 and it would say button 1 event, button 2 event again. And so that's how I was detecting solder bridges, is I would press that, and each time I press one, just make sure that I only got the response for the button I pressed. Then unplug it. Go to the second port. Do it again. Button 5, button 6, button 7, button 8. Watching on MQTT, unplug it. Go to the next one. As you can imagine, and then any problems that I was discovering, and there were a few soldered bridges between point pads on the resistor networks, I'd rework it, so I just move sideways under the microscope, do the rework to remove solder bridges, bring it back here, plug back in again, and continue from where I was. So as you can imagine, doing that process, plugging in and manually testing every button on every single port, when I had to test a few of these, I spent hours. I was sitting here for hours. It was most of an afternoon, I think, plugging in, testing, reworking, and plugging into the next one. It was just so slow. So I decided that I needed to do something about that and improve the rate at which I could test these, because assembling boards like this is basically it's a burden. It takes so long, and I would rather spend that time doing other things. So what I came up with, looking around, what have I got? Okay, I might even get to the point of showing you this, running these tests. What was I doing it on? Not that one. I will show it on, oh, I packaged them all. Okay, that's all right. So what I ended up doing was, now let's move that to there, using these short jumper cables and just looping them around. So yep, I've had a few suggestions for ways to improve this. People on Discord have been saying things like make up something with a whole lot of the plugs mounted on it, and then I can just shove them all in as one go. But this is not too bad. So I can set up all the loopback cables just by plugging them in here. And then the way this test works is that it takes advantage of the fact that the MCP 23017s are both input and output drivers. So in the case of this light switch controller, we're using them as inputs because we're reading from the light switches, but you can also drive them as outputs. So what I do is I've got a bit of firmware running on the rack 32. What it does is set all of them to inputs, and it then reads all of the values, and it makes sure that none of them have been activated. And that way it checks whether there are any shorts to ground or anything like that. So that's just the first test. Then what it does is take the first input, it turns it into an output, and it drives it low. And then it reads all of the other inputs and it checks firstly that the matching one for this, which is on the other port, it detects that it has been driven low, and it checks that no others have been driven low. And then it sets that back to being an input, moves on to the second pin, and does the same thing. So basically, once this is in this state and the test runs, the whole test runs in a fraction of a second. Like, I just press a button and it just goes burp, done. And it gives a pass or a fail, and if it gives a fail, then it tells me which things, where the error occurred, basically. So the procedure of testing these now, instead of me having to plug in every single one individually, is I set it up like this and then just press the button and it gives me a pass or fail, which is a much better way of doing it. So one thing I had been thinking about doing was on here I could do something like get a piece of plastic, like a strip of plastic, just as a like a structure, slide it down in between all of these connectors. Oh, and also I'd cut off all of the retention clips. So these connectors no longer have retention clips on them. And basically just put glue, like I could use araldite or something, and glue all of these together so that this ended up as a big block with all 8 connectors, all glued together as a single solid block with no clips. And then what I could do for testing is just grab that thing, plug it into all 8 connectors at the same time, run the test, and then just unplug it. And that's just a way of optimizing the process of plugging in all of these cables. I mean, I've spent more time talking about this now than it actually took me plugging in the cables. So it's not that bad. And, do I have, yes, I'll find a USB-C cable. Just looking at the, I think it might have been this one. I don't even remember which one I was using. I've got a few of these Rack 32s here now. I think this one, no, this one's got different firmware on it. But we, where is, sorry, I'm thinking through this now. So I want that and that. I need an Ethernet cable. I'm going to plug that into there. Plug power into here. I don't actually use Ethernet for this. I'm just using this as a way of getting power into the device. So I've got a like a PoE injector here, just a passive one with a cable that goes to an XT60 plug, my standard power connector that I have on everything. Plug that into my bench supply. No, first I better turn off the bench supply. What have we got it set to? 12 volts, 500 milliamps. That'll do. I'll turn it on. Okay, so we're now powering this via the bench supply. And yeah, oh, Mark Maker said, or just leave one clip in. Yeah, I think it's not going to fall out. It's going to be Stephen W said the ultra-thin Cat6 cables from 4 cabling would be nice for this, as they are very flexible. You can get them as short as 15 centimeters. Yeah, I actually have that. In fact, the reason, what's going on with this camera? Hang on, I'm going to switch back to desktop. Camera's frozen. I don't know if you can hear me. Can you hear me? It looks like there's audio. But I can't actually tell. I'm going to switch back to overhead camera. Okay, so my side camera is working, my front camera is not. All right, so, oh, you can hear, cool. So that's right, so Stephen W was talking about the Cat6 cable. So the reason that I actually have all of these Cat5 little patch leads here is because some time ago, I replaced almost all of the patch leads in my racks with Cat6 patch leads from 4 cabling. So that's why I've got a box full of these short patch leads. But yeah, the Cat6 patch leads would definitely be better, much nicer to use, much more flexible. Yeah, so that's right. I was just saying I don't think I would need to leave any of these clips on, because by the time you've got 8 of these plugged in, they're not going to fall out. It's not going to need anything to hold it in place. Mako said, cross cables? No, they're not. They're just regular patch leads. They don't need to be crossed. They could be crossed, but it really doesn't matter. All that would be is a change in the test software. So what I'm just going to do is I actually have Fusion 360 running in the background right now, and I wonder if that is part of the problem with the camera. Hang on, I'm going to turn off. Mistake, but I think it's back now. Okay, so I turned off video capture on the front camera, and that was also providing my audio, but it should be back now. All right. I'm just going to switch to the front camera, which is probably locked up. Yes. And now I think my side camera has locked up as well. It has. All right, I'm going to switch to Fusion 360 and quit it. And I don't know if that's actually causing this problem. Yes. So now there's just a still of me. Yeah, I don't know if Fusion 360 is what's causing the problem with OBS, but it does seem to be. Okay, yes, it's now a podcast. We have just switched to podcast mode. What else can I quit out of? I can quit out of QuickTime Player. Don't need that. I've got a few different things open here, and quit out of that. All right, so just to check, I'm just wait. All the video is locked up. Okay, that's really interesting. It's definitely podcast mode. So that overhead camera view, that is now frozen as well. Yeah. Okay, and my front camera has also locked up. Alrighty. Now, hey, earlier on, right at the start of the live stream, people were joking about pants being optional, and now that all my cameras aren't working, pants are optional. So, all right, what am I going to do? I'm going to try turning off the overhead camera, and I'll see if I can get the overhead camera back working at least. So this shouldn't have any effect whatsoever in what you are seeing or what you're hearing. I've just turned off the overhead camera, turn it back on, and we'll see if that restarts. No, it hasn't. Overhead camera, overhead. Turn overhead off, turn it back on. No, HDMI overhead camera. All right, I'm going to change it to USB camera number 2. Nope, that's not working. And USB camera, nope. This might be a really short live stream. Power cycle USB, work backwards. Boot the snoot, yes. So we now have really high bandwidth audio. Yeah. Okay, so what I'm worried about though, yes, people are telling me to restart USB devices, but what I'm worried about is doing that and killing the stream entirely. So the one thing that is working right now is audio, which is coming in on the HDMI capture device. So what I'm going to do is I'm going to switch to desktop. Okay, now can you see my desktop? Yes, the desktop is live. All right, I'll turn off the multimeter interface. So at least you can see, okay, you can see a weird picture of me frozen. You can hear me and you can see my desktop. That's really all we care about. As long as there's a weird picture of me frozen, then it's all good. So, what was I looking at? That's right. I want to have a look at, I was going to look at the I2C thing, and yeah, I'm sure OBS would recover. But if I'm showing you stuff on the desktop, then it doesn't really matter anyway. So, yeah, so this is my project folder for the I2C breakout. And if I go into tests, I've got this thing. Now, if I open, that should be okay. Close that. All right, so this is the little test thing that I was running, and it is super, super dodgy. But it's one of those things where so it doesn't do auto scanning, for example, which is in the latest LSC firmware. It's just got a hard-coded number of chips, and it's based on a kind of cut-down version of an early version of the light switch controller firmware. And so what it does is it just has a single flag at the moment for a test failed saying false, and yeah, what am I talking about? Tester, okay, scans the bus. It's got a couple of bogus values here. I'm not going to go through all of this. It's you don't necessarily need to know the details, but it's so what it does is most of the things are done in setup, because I only actually care about this running once. In fact, where's loop? Loop probably, look at this. Loop has nothing in it. All it has is all this commented out stuff, which is the thing where it's scanning the. So this is the code from the LSC project, which then became the USM and stuff. So, in fact, button press. I don't think this is even used. There's stuff in here that isn't even used anymore. That's how dodgy this test thing is. So, what the interesting bit is. Okay, what have we got? A couple of loops. So we've got a loop in a loop. So what we do is we step through, the outer loop is each of the target chips. And I was using this for testing the 16 port boards, and that's why I've got MCP count as 4, because there are 2 for every 8 sockets on the inputs. And then here we've got the outer loop, which is just stepping through those 4 and incrementing the target chip that it's wanting to test. Inside that, we've got another loop, which is stepping through each of the pins on each of those chips. So this will go to chip 0, pin 0, then chip 0, pin 1, etc. And then what it does is set the target pin to be an output and drives it low and waits 10 milliseconds just for the world to settle down. I don't even know if this is necessary. I should just take this out and see if I get any test failures. But anyway, 10 millisecond delay in there just to make sure that the MCP has had time to respond and drive its output before we start reading it again. And then we run test input states, and we tell test input states what our current target chip is and target pin. It needs to know that, so it knows which is meant to be the matching pin for the other side of the loopback test. And then it just resets it. So it sets the target pin high. In fact, this line here, oops, is probably not even necessary. This is taking the pin that we were driving low and setting it back high before turning it back into an input. And yeah, so this line could probably be commented out, because when it goes back to being an input, it it will probably, the reason I'm prevaricating on this is that there are situations, the reason that I explicitly drive it high before setting it back to being an input is that there are situations in Arduino where changing the drive state of a pin can change the pull-up state. And so what I wanted to do was make sure that it was explicitly high, and if it did enable input pull-ups as a result of doing that, then it would not screw up the test. So all of that is, this line could probably be commented out. It's probably not necessary, but it's in there just to make sure that nothing goes wrong and that we absolutely know that that pin is going to be left in the same state as it began, which is being driven high. And then it sets it back to being an input, increments to the next pin, does it again until it gets to the next chip, and then loops through them all again. So then if the flag, after all of this, if the flag is set saying that the test has failed, it says test failed, otherwise it says pass. Now, test input states. This is what it's calling for every one of these things. So what we do is we loop through every pin on every chip and call this, and then every time that's called, it also loops through every pin on every chip, and it checks. This whole thing is, this could be deleted as well, but what this is doing is just, if we've got these the special flag set, so we know that we're doing the first pass test, what it does is just check that every single pin is high, because nothing is being driven low at this point. And what that is trying to check for is things like pins that have got solder bridges to ground. And it sets the test as failed if any of them are set to low. And down here, so once again, we're doing lots of looping, loops in loops. And this is checking for the offset. Now this is actually kind of dodgy. It could be improved, but it's good enough for government work. So what this is doing is saying, if we are testing, no, ignore the chip bit. It's saying, if the pin that we are looking at right now is offset from the target pin, either -4 or +4, then it should be the chip, it should be the pin that is matched to the one that we're currently looking at. Now the reason for that is that if you're testing pin 1, the loopback pin is going to be pin 5. If you're testing pin 5, the loopback pin is going to be pin 1. It's going to be offset because of just because of the way the cables loop around. And this is not actually as tight as the test should be, because it should know which direction the offset is in based on the current test. But it works. Like, this is, there is a very, I've been trying to figure out a scenario in which the looseness of this test could cause a problem. And the only way that could cause a problem is if there's a solder bridge that is between multiple pins and it misses a pin in between, or some crazy situation like that. So mechanically, I think it's almost impossible for this not to work. Yeah. So if it was a problem, I would have it figure out whether the matching pin is 4 above or 4 below and only look for that. But at the moment it checks for both. Yeah, so if it does find something that is failing that, it blaps out a whole bunch of stuff and sets the test flag. Anyway, the point of all of this, yeah, and as I said, button pressed is never called, scan I2C bus is never called. I think I should just delete that. So the result of all of this is that I can plug in those loopback things, with the console open, just press reset. In fact, let's see what we've got. I'm going to change the board to ESP32 dev module, and I'm not sure what firmware is currently on that rack 32. I think I was using it for testing for some other firmware stuff. So port, I want that one, and compile and upload. And we'll see if this little test setup works. Now there was a comment in the code down here, somewhere here. No, not there. Here. It says, need to suppress error if this one has been reported already. Now that is, well, what happens is that it'll report the error for every single time it loops through. So we get the same report over and over again, which is kind of annoying, but it's not that bad. And you just get a whole bunch of the same error messages coming up on the screen. Done uploading, what have we got? Okay, let's open the console. I'm going to press reset on this. I don't know. Okie dokie. Oh, pass. Okay, so it just ran the test. So what it did was check for the MCPs, and it found the first 4. And so, obviously it is calling that scan I2C function. Where is it calling that? It'll be here in, oh, there we go. Scan I2C bus. Yep, so that's how it's initializing them. So we do need this. It's, yeah, okay, cool. But we're not doing I'm pretty sure we're not using button pressed. If I deleted that, I'm just going to try it. And then try compiling it again. It should not complain. And you can see that in this case it passed. Now, I'm going to try switching. Yeah, done compiling, so it's okay. So this is the output of the test. It's found the MCPs, which is a good sign. And then everything has passed, so it's just said it's good. So I'm going to try simulating an error. I'll leave that on the screen. First, just to see if it's recovered, I'm going to switch back to front camera. No, it's still frozen. Back to desktop. And I wonder if overhead camera has recovered. No, it hasn't. Okay. I wonder if the microscope is working. Let's try this. Is the microscope turned on? Yes, it is. Microscope view. Ooh. No, OBS has definitely freaked out. Okay. We'll just have to stick with the desktop for now. All right, so what I'm going to do is unplug one of those cables and we will see what happens. Now I'll just press reset on that. Oh, it passed. Oh, that's because I'm checking for, oh, hang on. Am I even scanning that? I'm just going to try doing that. Yeah, I'm not even checking for that situation. Now, what I'm going to do is, I've got a pair of tweezers. I'm going to try, okay, I'm going to stick this pair of tweezers in. I'm actually not sure if this test setup is working properly. It says pass. Yeah, this test setup is not running properly. It should have failed on unplugging one of those things, and I just stuck some tweezers in to short out a couple of the pins, and it failed to detect that. So I've obviously not got this working. Anyway. What is it doing wrong? We could do a debugging session on the tester here, but it's probably not worth it. Or not the sort of thing to do on a live stream anyway. What I could do is, I'm curious. I am curious. I'm going to just uncomment all this debug stuff, upload it, and see if we can get it to tell us what it's testing, because this might indicate why the test says it's passing when it should be failing. Uploading. There we go, you can see it's working through everything. It's taking a long time to run, but that's because it's actually limited by the speed of the serial console and the fact that it's got to output all of this information. So you can see it's gone through each of the target chips and checked pin 15, so the target pin is 15. So this information, it's not very clear. This was just like, if we come back to here, what it's doing is telling us what our target chip and target pin are. So that's the thing that we are testing, and then the chip and the pin is what we are currently reading. I could have used better variable names here as well. So what it's saying is that we are currently testing chip 3, pin 15, and then we're going to read chip 2, pin 8, and it's high. And then we are still testing chip 3, pin 15, and we're going to read chip 2, pin 9, and it's also high. So what this is doing is showing what pin we're currently driving, and then what pin we are cross-referencing, and what value we're getting from it. So this is testing, so what we should be seeing, if we scroll back up here, if we go to chip 3, yeah, this test is definitely not working, because what we should be seeing is some of the pins being pulled low as well, and we're not seeing anything pulled low, so it's failing to drive the outputs. So demonstrating my little tester has been a total fail. We failed the test. The tester failed the test. Yes, interesting. Hang on, I want to go all the way back to near the start, because I want to see the outcome. Oh yeah, so this is the outcome when everything should be high. So it's got this 99 value is a bogus value, because it's never going to get to chip 99 and it's never going to be pin 99. So basically I just use those values as flags, which is lazy. And that tells it that it's not trying to test a specific pin, it is just trying to check every single input and make sure that they're all high. All right. Yeah, Peter says maybe I should feed copy to my OBS machine. Cool. All right. Okay. Jason example. Oh, yeah. Okay. So while I'm talking about this boring stuff that's not even working, people are talking about interesting, useful things. All right. So, because this is not being a very good demonstration, I'm going to try, do I want to save? No, don't save. I want to try recovering OBS. Now, this could be really dangerous, because I might kill everything. So, what I'm going to do is I am not going to end the stream. I am going to quit. What have I got running? Got all the usual stuff running. I'll quit out of preview, basically. Oh, that's from because we're looking at the schematic. I'm going to quit out of everything I don't need. I've got OBS running. I've got Discord running. Actually, I'm going to quit out of Discord as well, just to, so I've got touch portal for changing views, browser. That's it. That's about it. Well, all right, let's kill off iTerm as well. Quit out of iTerm. So this is about as minimal as it gets. I've got Finder, I've got OBS, touch portal for doing camera changes, and the browser. That's it. All right, so what I'm going to do now, and I may not come back from this, so just in case, I'm going to bid you all good day, and I'm going to quit out of OBS, turn off the USB devices, turn the USB devices back on, start OBS again. And hopefully in about 1 minute, I will be back, maybe with a working camera. So I'm going to hit, actually the first test is I'm just going to stop streaming. No, okay. All right, give me a moment and let's see what happens with this. I think I'm back. It looks like I might be back. So, am I here? Am I here? Yay! Def bomb, yay! Cool, so that worked. It didn't kill the stream totally. So now I should be able to go to, say, desktop. I should be able to go to overhead view, and yes, we have live cameras, live side cameras. Everything is live again. Okay. Alrighty. Where, so shiny, yes, Peter. I should have powdered my head. What am I doing? I don't know. I have lost the plot. Espresso machine or bust, yes. I actually have a proper coffee machine that my family bought me for my birthday. I think it was 2 birthdays ago. So, was it? Yes. So just a bit over a year ago. And I used it a fair bit when I first had it. And then usage of it has sort of trailed off over time. And so, yeah. I think after this live stream, I'm going to go and use it again. I'll fire it up. It's one of those Nespresso things. Part of it is that I'm not a huge fan. Well, cleaning it obviously is an issue. It's pretty easy to clean. That's not really a problem, but you still got to clean out the milk frother and all of that sort of thing. But also, I just try to reduce the number of pods that I'm putting out into the world. So I do use it, but it's more like ooh, I would like to make a proper coffee sort of thing. And no, I know pod coffee is not proper coffee. I'm going to have coffee snobs yelling at me as well. Jax Tech says, can get the replaceable pods, yes. And, Aaron has raised a really interesting thing. I will get back to that. Jax Tech said, as in the refillable ones. Yeah, so with that, I guess you would have a coffee grinder and get some beans, grind them, put the things into the pod, put it in. So it'd be kind of like using a coffee machine that uses the paper filter, except that instead of putting the coffee in and tamping it down, you put it into the pods and put the pods into the machine. Is that right? I don't know. Anyway, Dodgy says, I restarted the wife. She is making the coffee. Good job. And it's good that she's taking care of your caffeine needs. All right. Martin says, Breville Barista Express for the win. Real coffee and clean takes me 4 minutes max. Nice. Breville Barista Express. I am frantically typing that into Google. Oh, that's a fancy looking machine. Yeah. Okay. Yeah, that's really taking that cafe experience and putting it in your own home. It actually looks a lot like the one that we used to have at IVT. I think it was very similar to that. I can't remember what model we had, but for a while we had a proper, grind the coffee and sort of make it machine. I don't remember what it was though. Yes. Second-hand, $180. Ooh. Ah, yes. And KY4BQ says, I use an AeroPress. I've heard the term AeroPress. I don't actually know what it means. AeroPress. I know it's something to do with nice coffee. AeroPress coffee maker. Okay, I've just Googled it. It's a coffee machine. AeroPress. Oh, I see. So you put the thing over the thing and you push it down. So it's like a little brew thing that then filters it through into the cup. Why am I talking about making coffee? I don't know. Making coffee is not the squirrel that I expected to be chasing. But it's, yeah. It's an important squirrel sometimes. Yeah. Oh, Martin says, a lot of people buy machines and then give up after 6 months. Suits me, this one was hardly used. Yeah. And James O'Gorman says, I have the $15 Walmart special with us on off. So I have just as a general, like a hot water jug thing, I have the Kogan kettle with Wi-Fi, and it currently has a 2-year, so it's running the 2-year firmware right now, but that is going to be Tasmatized. And the only reason that I've had that kettle for, must be 6 months now. The only reason it hasn't been Tasmatized yet is I've been waiting to do it on camera. So, yeah. Oh, Andrew said, so the Arduino IDE is working okay on the M1? Yes, it did. And yes, it does. And it's fast. For me, the comparisons aren't necessarily indicative of everybody else's experiences, because I'm coming from a machine that was 2012 model Mac, Intel based, and on that, Java is slow anyway, pretty much everywhere. Java is just slow, not necessarily the fault of the language, but the way it's implemented a lot of the time, projects can end up being very heavyweight. And the Arduino IDE is all Java based, as in the current version, well, not the Pro IDE, that's a different story entirely. The regular Arduino IDE, I'm pretty sure, is all Java. And on my 2012 Mac, which is what I've been running since 2012, it was quite slow. Like just doing something as simple as clicking on the File menu to go down and select out my sketchbook, I could click it and then wait 10 seconds or 15 seconds before the menu would open, just to generate the list of files. And on the M1, it is so much faster. The UI is faster, but also compiling is faster, much faster. Yeah, Andrew says, my current desktop is a mid-2012 MacBook Air. Yeah, my two main computers up until just now has been a 2012 MacBook Pro, which is actually on the bench. If I slide sideways, you'll be able to see it, I think. Where is it? Which way? No, it's not there. It was there. I moved it. It must be inside the house now. So a 2012 MacBook Pro and a 2013 iMac. And now, right now, thanks to all of you fine folk that contributed, I'm using an M1 Mac Mini, which is such a better experience. Christopher said, where is that Kogan kettle? Could you flash it to Tasmoda now? It's inside the house, and it will take a little bit of setup. So it's not the sort of thing that I will start at the end of a live stream. Yeah. Okay. Where were we? That's right. If this was a drinking game, I'd be taking a drink. Now, updated to, sorry, I've got right in front of me Aaron's UT61E Wi-Fi firmware, and that's just because we were looking at it earlier. All right, I've got to close that tab, close that one, close all the things. Next week on Superhouse, we flash a kettle with Tez motor. Yeah, actually, that reminds me. There's one of the smartest people I've ever met is someone that many of you will know, Andrew Tridgell, or Tridge. A while ago, he became really obsessed with coffee in classic Tridge fashion. You know, he's the sort of person that when he becomes interested in something, give him a little while and he will suddenly be the expert in that thing. And yeah, many years ago, he did a talk at LCA about building a coffee roasting system. And so he'd never done any electronics, like never actually soldered things or, you know, put things together. But he wanted to solve this problem. He wanted to make a coffee roaster, and he was very particular about the specific temperatures and durations and the profile and all of that sort of thing. So he learned all about it and made himself. He learned how to solder and made all the temperature control stuff, and then did a talk at LinuxConf about coffee roasting. Yes. And then he became interested in flying robots, and now we largely have him to thank for the current state of ArduPilot. Yeah, his obsessions turn into... When he becomes obsessed with something, the result is that everybody else benefits because he does something amazing with it. What am I talking about? I don't know. I am totally at the rambling stage of the live stream. I'm just going to do a search. Andrew Tridgell coffee. Coffee roaster. Yeah, so that was in 2010. 2011. Yeah, Penguin powered coffee. So 2011, he did a talk at LCA. So that would have been January 2011. About his Linux-powered coffee roasting system. Just wondering if there are any pictures of his homebrew coffee roaster. Oh, yeah, that's right. He made it out of... Yeah, there's a hot air gun. Anyway, this is a silly side track to be going down. What am I looking for? Okay, I've lost the chat. Where is the chat? Oh, okay, there's a window that was out of my view. It was hidden. So, what have you all been talking about while I have just been... yeah, Java... So, well, you've all been talking while I haven't been able to see it. JaxTech said there's a Node-RED plugin for Tuya. Yes, there is. And there is Tuya Local, and there is now just recently the official Tuya integration for Home Assistant. But stuff that. I'm going to Tasmatize it. But, okay, so this is the other thing that I'm going to do. My wife always turns off the power point that the kettle is plugged into. So in the morning when I get up, the kettle is turned off, obviously, because there's no power to it, and the power switch is also turned off. So I turn on the power switch, which then starts up the kettle. The ESP wakes up and it throws up this little thing, and then I can start the kettle. So my plan is that I'm going to put a like a Wi-Fi power socket in on the wall there to replace the one that is the manual switch, and also Tasmatize so that'll be Tez motor controlled, and also Tasmatize the kettle. So what I want to be able to do is with one voice command, I'm not going to say it right now, but say something like, you know, she who shall not be named, turn on the kettle. What it will do is turn on the power point on the wall and then wait a couple of seconds for the kettle to boot and then turn on the kettle. So you can take care of all of it in one go. All right. What are we talking about? That's right. So I just saw a comment here. So Andy said Java JVM slow startup, but after that JIT, so just-in-time optimization is fast. GC may cause intermittent pauses, which is garbage collection. Yeah, one thing I've noticed also, I don't know, I'm just observing this from the outside, but one thing I've noticed is that maybe there's some interaction between the way Java works and calls to the operating system, because the place that I notice that it's slow in particular, so in the Arduino IDE, is if I have the IDE open, click the file menu, and then go down to the sketchbook, the sketchbook menu item, which then pops out a sub-menu with a list of all of the sketches in the sketchbook. And that takes ages. And I have a suspicion that it's because of the call out to the operating system to do the file system operations to get the list of files in the directory. So yeah, I don't know if it's Java that's slow in particular, or if it's some interaction, like the fact that Java is saying to macOS, give me a list of all of the files in this directory, and it's iterating through them to build up the menu, and that's taking a while. Yes. Stephen W. said 10-minute warning for lunch. Okay, so I now have 3 people who keep an eye on my lunch status. So Peter was mentioning it earlier, and Chip said, yeah, what's lunch? So I'm in no danger of running overtime, because everybody's going to be telling me, stop for lunch, stop for lunch. Chris says the Dita power switch is pretty good and tasmatizable. Yes, I've done that. So that's actually what I was going to use. I have a Dita double outlet power point. So those are the ones that are to you normally. I have one at the moment in the back of my garage where the drill press is. So I've got a couple of drill presses. There's like a regular drill press which is sitting on the bench, and I've got a large drill press which is like a floor standing one, which is like as tall as I am, and that's plugged into a power socket on the wall, which is one of those Dita power sockets. And I've also got lighting for the drill press. So there is like an LED array mounted on a flexible arm attached to the back of the drill press that shines directly into the work area. And that is also connected, that's powered through that same switchable power outlet. And so, what am I thinking about? That's right. So anyway, my point is, yes, the Dita, in fact, didn't I do a video about them? I have a feeling I did a video about them. Let's see. There was a Tasmota conversion video. Yes. Check this out. Hang on. I've just got to move something out of the way over there. Move this over here and switch to desktop view. All right, so dismiss that. Move that in. Yeah, so this one, the 6922HA double power point, this one has, no, this one doesn't have power monitoring. That's one of the limitations of this, which is unfortunate. But yeah, I did a whole video about how to do the tasmatizer and the pinouts on it. If you want to, yeah, so this one I can't remember. I think with this one, they are now shipping it with firmware that does not allow 2-year convert to work. So it used to be possible to flash these ones with 2-year convert, but I'm pretty sure it doesn't work anymore. And then, yeah, I've just got a whole bunch of photos of it and etc. So you need to do the serial conversion method. And so I've got the pinout here that shows where to find all the connections on it, and flashing connections, tasmatizer instructions, etc. Anyway, that one, yeah, so that's my plan. I'm going to stick one of these on the wall in the kitchen so that I can, when I tell the home automation system to boil the water, it'll make sure the power point is turned on first and then turn on the kettle. All right. So, oh, Kevin is defending Java as well. All right. So Kevin says, yes, just-in-time optimizers based on the actual CPU. It's aware of different instruction pipelines of an i9 versus an i7 versus ARM. Many tests have been done that show that JVM is really as fast as native code. Yep. I'm not trying to bash on Java here. So Java, it's just been my experience that Java projects often end up very heavyweight, and I don't really have much experience with it. So, and the Arduino IDE in particular seems to be very slow with its menus. All right. Oh, Chris says, I did mine 2 weeks ago and had to flash it the serial way. Yep. Oh, Realtek chips. Stephen W. said they are Realtek chips. Maybe they've changed it. I did hear that they were, that Dita, is it Dita? Who is it that makes, Peter sending me messages. Yeah, the Dita is a range. It's, who is it that makes it? I can't believe I can't remember. Grid, no, that's right, Dita is the brand. Yeah, so it's Grid Connect, which is TIA. Okay, what am I saying? I don't know. Yeah, anyway, I did hear that Dita is changing over to Realtek, the Realtek equivalent of the Espressif TIA modules. All right, now, Peter said that wasn't meant to go ding. All right, this live stream is me reading, just because he said it wasn't meant to go ding. Oh, okay, so this is the live stream of John reading Peter's messages. Have an Ethernet socket. The short answer to your question, Peter, is no. I'm not sure. It seems like an innocuous question, but the fact that you send it to me directly rather than posting it in the chat here makes me wonder if you didn't want the question to be public. So I won't actually say what the question was, but the answer to the question is no. Nobody else has any clue what's going on. But maybe someone in the chat here does actually know an answer to your question. So if you feel like asking the question publicly, you could do it. And then you could stick it in here and maybe someone will answer. All right. So Aaron said, maybe this is a good thing to wrap up on. I will just, the question was 42, yeah. Anyone else hungry? Yes, it is time for lunch. But Aaron did say something that is hard for me to repair. Okay. I am totally losing losing the plot, which shows that it is time for coffee. It is time for lunch. But I'm going to mention the one thing that Aaron prompted me on just a moment ago in the chat, which is a status report on the universal rack controller and the mechanical enclosure, because this is actually kind of cool. Anyway, the next thing, apart from verifying the PoE and that sort of stuff, the electrical side of things for the module and ordering the PCBs for the pass-through version, and there are other things that need to be done. The really big thing in front of us right now for the universal rack controller is the mechanical side of it. And you've seen my my attempt. This was the thing that inspired the URC. Oh, there's a sticker under it. And it became the URC project, kind of spun out of this. So this is the light switch controller, and that is the old version of what is now that. And yeah, instead of having the Pi in here, I'm going to have the rack 32. Where there, somewhere like that. But anyway, the mechanicals of this was just my minimal first pass at making a rack enclosure. And I wanted to keep it as simple as possible because I was just trying to prove out the concept. And so this is a single piece of steel that has been laser cut and folded. And then so these holes that are in the front, I cut these by hand. Well, by hand, I use power tools, but still, I did it manually. This was not laser cut on the front. The shape, the general shape, like all of the tabs and everything, this was all laser cut, and then it was CNC folded. So I was put into a big fancy folding machine, which I just found out a couple of days ago. The folding machine that did this was worth $600,000, which it boggles my mind. But anyway, there's a whole story to that. This live stream could go on way longer. So what I want to do is do a proper thing. So there are two stages to this. Step one, so this was my concept, was to just buy an off-the-shelf rack enclosure, find something that was close, and then CNC machine the front panel and paint it and all of that sort of thing. Because that way it's, and I might still end up doing this. I've actually been talking to a Chinese supplier, a company that makes rack enclosures. They make lots and lots of different designs and they can customize. So they can do them to different depths and different surface finishes and that sort of thing. There's an MOQ for customization, but in the very short term, what I was thinking of doing was just buying off-the-shelf rack mount enclosures and then machining them, because I could do like 1 or 5 or 10. It's you can start with very low volume, and then ultimately, if we can get to some kind of scale, like say we need 50 or 100 or multiple hundreds of them, that's when I would go to custom manufacturing. But sorry, Peter just distracted me with another message. I'm going to ignore it because I need coffee and lunch. So I have, there are several people that I know very well, let's just put it that way, who work, one is my brother-in-law and a couple of other people who I know very well through other ways, who work in fabrication, including CNC cutting and all of that sort of thing. And one of them, a friend of mine named Steve, who I might have mentioned on a live stream before. So most of his career has been building race cars, like supercars. And for people that, if you're in Australia, at least you would know very well. So he has a factory just down the road from me. It's only like 5 or 10 minutes drive away, where he has lots and lots of tools, multiple CNC machines and things. Anyway, he came over a couple of days ago and I showed him this and said, you know, I'm thinking of prototyping something like this, like a more advanced version. And he said, no worries, come down to my factory and we'll cut it on the plasma cutter. So it turns out that he has got a, oh no, not that Steve, it's a different one. It's not Steve the squirrel. No, this is a different Steve. So we need some distinction between the two. So anyway, he has got a factory full of heavy equipment that that is used for making stuff. And so he said, yeah, model it up in Fusion 360 and send me the files and come down and we'll cut it on the plasma cutter. So what I'm going to do sometime really soon, probably in the next week or so, it actually depends a little bit on lockdown limitations and all sorts of stuff. There are other factors at play. But what I'm going to do is go down to his factory and we're going to make some custom enclosures on his plasma cutter. And so the really cool thing about this is that it will mean that we will have flexibility if I end up going down this route. Now, admittedly, this is a very hands-on way of doing it. It would mean me using my time rather than simply outsourcing someone to do the production. But what it could mean is that we could do versions of this with customized front panels based on whatever people want to build. So what we could do is have a standard design of the enclosure, and the basic metalwork is set up so that we can cut that out on the plasma cutter. And then if someone wants to do a version of this, which is like the stuff that's been talked about in Discord, things like the smoke detector management system, and there are certain connectors that you want on the front, what I could do is you could draw up where you want the holes to be for your connectors, send me a drawing, and then we could do like a one-off version of the enclosure. So we could possibly do a customized enclosure service, which would be amazing. I don't know if it's, yeah, Frank says, I think we're going to be locked down for a while. Yeah, it's going to be weeks more, I think, at least. So, Plasma Steve, not Squirrel Steve. So what I'm thinking of doing is taking a camera to Steve's factory. And I did mention this, I talked to him about this, and he's really happy to do this. He's very happy for me to like film this whole thing and show you how it works. Yeah, so as Christopher says, just-in-time enclosure manufacturing. Yes, exactly. So sometime very soon, I might be down at Plasma Steve's factory with a camera showing you his plasma cutter in operation, which would be super cool, and showing you making URC enclosures. Oh yeah, Amanda says, yeah, all of New South Wales is now in lockdown. Yes, it's getting worse. So, yeah, I don't want to get into that subject because it's now too much, because it's now definitely lunchtime. Oh, Aaron said, so steel then. That's the big question. There is the issue of should this be made in steel or aluminium? And my personal preference, what I would lean towards, is aluminium for two reasons. Lightness, and also for ease of being able to rework it. So if we do a version that has a blank front panel, or that has, well, not necessarily totally blank, it could have the display on here and the rack 32, so Ethernet and USB and power on this side, blank in the middle, so that you can cut it to put whatever you want in here. If it's steel, it's harder to cut and work than if it's aluminium. If you're just using tools like drills and panel nibblers and the sort of stuff that you would use just in a little home workshop. And so my preference is to do it in aluminium, but from a manufacturing point of view, it may end up being cheaper and easier to do it in steel. And part of the problem with this one is that I slightly over-specified the thickness of it. So all of these holes I drilled holes and then used a panel nibbler and cut the rectangles out and gave myself blisters and cramps in my hand and everything. It's really hard, but that's because I over-spec'd the thickness of the steel. It doesn't need to be this thick. So Plasma Steve suggested that I go for maybe like I know steel is normally specified in gauge. It's not in thickness, like millimeter thickness. There's kind of equivalence. This is approximately 1.2 millimeters thick. So he said go for steel that's, you know, about 1 millimeter thick, which he said normally ends up being slightly under a millimeter. When you go to the gauge equivalent, it ends up being like 0.91 or 0.92 millimeters or something. So I think that would actually end up being easy enough to work that if you wanted to cut holes and put it in yourself, you could. It wouldn't be a huge problem. And to have the same sort of level of rigidity, aluminium would need to be thicker. So it's a trade-off. I don't know. Mr. Fixit said, do the cases come unpainted? At this point, everything is up in the air. I just don't know. So what Steve suggested is we will powder coat them. So what we would do is, I'm going to buy just some raw steel sheet. So cold rolled steel, probably 1 millimeter, and I'll get a sheet of it, take it down to his factory. We will laser cut it and fold it into shape, and then probably powder coat it. So the thing is that if it's powder coated, and like if I have a blank one and I powder coat it white and then you cut it, there are going to be exposed metal edges where it's been cut. So I don't know how to deal with that situation. Yes. I should stop, shouldn't I? Yes. Do a live anodizing show. Yeah, so Dodgy says, when do we see a 32-port version of the LSC? Yes, I can do that now. So part of the reason that I limited this to 24 ports was this. I was fixated on the idea of an I2C display and buttons on the front panel. Now those buttons are on an MCP, which means it was using up some of the I2C addresses, which means I could not put 24 ports across here. No, I couldn't put 32 ports, I could only put 24 ports. But that's all changed now. Yeah, my original goal was that all of the pieces within the enclosure should be connected over I2C. Now that I have kind of backed off from that, and I've gone for SPI for the display, and there is no longer the buttons directly on it, although buttons could be put in there, but they could be done differently. So that's no longer a limitation. And mechanically it would all fit. So what you could do is you could get two 16-port modules and mount them side by side. That would fit. Or I could do a new version, which is an integrated single PCB with 32 ports on it. Either way would work. All right. Is an add-on 24-port adder a possibility? Ooh, Mr. Fixit. So you've got a powder coating oven and a CNC plasma. Awesome. So, can we outsource making the cases to you? Stephen W says 15 past lunch. All right, 15 past lunch. It's time to stop. This has been a weird live stream. It's felt weird to me anyway. I think maybe because I was discombobulated by OBS freaking out and things I was trying to demonstrate not working. But that's what happens. All right, I am going to go, and I will then check Peter's other message because he sent me another message. And yeah, that's it. Okay. Thanks everyone. Thanks Aaron and Chris and James and Mr. Fixit and Stephen W and Defpom and Kevin and Aaron, Dodgy. Anyway, I gotta go. I gotta go. I gotta end it. Okay. Where is it? There's a big end button right there. I'm gonna press it. I've still got to do the big red end stream button. That would make this more fun. All right. Bye.